Welcome to Logistics Business Conversations, where we talk with key spokespeople in the logistics industry about topical issues. Hosted by Peter McLeod, editor of Logistics Business magazine.
Good morning, good afternoon, good evening, wherever you are, and welcome to the latest edition of Logistics Business Conversations, which is brought to you today by Robotics. My name is Peter McLeod. I'm the editor of Logistics Business magazine, and it's my great honour to host today's podcast, which is called The Future of High-Density, High-Performance Solutions with Robotics. Last week, I was honoured to be invited to visit the warehouse of one of Robotics' customers, Fox Logistics, in Rotterdam, to witness the launch of Project Nexus, which is a suite of automated technologies designed to work together to bring efficiencies and cost savings to warehouse operations. To help steer me through these new products and services, I'm delighted to be joined by Damien Skinner, Country Manager of UK and Ireland for Robotics EMEA. Hello, Damien, and thank you for joining us this morning.
Good morning, Peter.
So before we drill down to the specifics, can I start by asking you for an overview of Project Nexus, please?
Yeah, so Project Nexus is a latest development of our ACR technology. ACR stands for Autonomous Carton Handling Robots, where we have basically stretched the technology to create high density and high throughput systems.
So we're not talking about a specific single item of technology. It's like a collection of technologies all working together. So can we have a little walk around the solution? I notice you've bracketed sort of solutions into three sort of versions. You've got high-pick systems 1, 2, and 3, depending on the type of customer operation. So shall we start by maybe just having a little look at those?
Yeah, sure. So at Robotics, our focus is on our ACR. And for those who don't know what an ACR is, think of it as like a roaming mini load crane. It's an autonomous robot that can roam around an enclosed area with storage and retrieval for goods to person picking. And then what we do is then leverage that technology further for high picks 1, 2, and 3. So with Hypic 1 is our, I'd say, most basic system at the moment, and that is simple goods-to-person robots up to 5.2 meters for a fixed mast robot, or up to 10 meters for a telescopic robot, where we can bring totes via a supplementary technology called a high port, getting up to 500 totes per hour per pair of high ports, bringing goods to person for picking and storage and retrieval. Then we have Hypic System 2, which is a combination of ACRs and more traditional AMRs, where in the same footprint we can handle awkward goods or pallets or stillages to a multi-purpose workstation. And then we have our new Hypic System 3, which is using our ACR technology with a very fast-moving complementary robot, which means we can then pick directly from that robot at much higher speeds than we would with more conventional conveyor-based technologies.
It was there was a lot of information to take on board there, and when I was at the launch last week, System 1 was described as flexible, System 2 as versatile, and System 3 as powerful. So I think really, it sounds to me like you've got all bases covered there. And I think one of the things that particularly caught my eye was the density of storage. Now, sort of automated pick systems have their restrictions, generally speaking, but I think High has come around is looking at the challenge from a different angle. You've got a very interesting system where you can actually go 5 deep with your cases. So it's a very, very dense storage system. Can you just explain how that 5 deep works? Because we're not talking about gravity-fed racking, and we're not talking about powered racking. What is the system that you use, please?
That's right, Peter. What we've developed is basically a unique unique load, a unique tote, which has features, interlocking features, so that we can store and retrieve up to 5 deep, 30 kilo unit loads, and incredibly high density. Um, Basically, the totes have zero distance between them. We call it chain technology, so that when we want to retrieve totes, we can pull the chain forward, finding the totes that we actually require. So the unit load, uh, the load handler, sorry, on the robot itself has like a grappling hook, so that we can then interface into the front tote, pulling them forward to shuffle to the tote that we actually require.
Right, so as the front case gets pulled slightly downwards, it disengages from the one behind it, and then that one behind it now becomes the front tote. So that overcomes a lot of the challenges around, should we say, other competitive systems, for example, a cubic system such as AutoStore or an Exotech system, where they have limitations about where the pick face is.
Yeah, that's it. I think the limitations with some of the cubic stores that are on the market today is more about the accessibility of the totes, and the amount of digging that's required, therefore increasing the number of robots required to meet the throughput demand. With this solution that we've developed, it means that we can use the ACR technology to do the storage, retrieval, and digging, limiting to the number of totes that we've got in storage in terms of the depth, and then using like a fast companion robot to do basically the legwork, so the higher throughput store retrievals and presentations to pickers.
So what sort of customers would you suggest would be attracted to this sort of solution? You know, in terms of their type of business or the sort of throughput they're looking to achieve.
Yeah, so generally we're looking at markets in e-commerce for apparel. Um, Many of the 3PLs are interested in the technology we have in offer, but it could be generally any application such as electronic goods or general merchandising, for example, but generally around the apparel and e-commerce markets.
So fast moving goods and e-commerce would be a core customer there. You've actually surprised me there by saying apparel as well, because I'm just thinking in cubes and blocks. But you're suggesting there's perhaps maybe a hanging garment
Yeah,
capability here.
certainly for Hypix System 2, we could look at hanging garments and using the larger AMR robots to use for hanging garment presentation to pickers. But generally, when we're looking at apparel, if you think about footwear or seasonality, using the storage depth are actually using to our advantage, where we could use, summer stock could be stored during the winter, and then you've got the SKU churn as the seasons change. So you've got that flexibility there. One of our key advantages, that flexibility at high, to allow us to store all manner of SKUs over that operational period.
A few years ago, I had a very interesting visit to an automated shoe warehouse, and the technology there was ideal because all you were dealing with was a box, either a box for baby shoes, which was the smallest box, or a box for, should we call them kinky boots, which was quite a big box,
Yeah.
and that's almost like the perfect customer. But nowadays, of course, we need to handle irregular shaped objects as well. Do you have the flexibility within the system to do anything outside of the box, shall we say?
Yeah, so Hypix System 3 is designed for a 650 by 450 footprint of unit load, giving us more units, certainly like when it comes to shoes, as you said there, Peter. So it gives us more fill per tote. You on average 6 to 8 shoe boxes per tote. But if we've got irregular shaped items or say awkwards or bulkies, Then we can start looking at the Hypix System 2 application, where we can use the AMR to store in stillages or cages or pallets, and then present that to our operators for picking.
Right, and your customers are going to be asking you from day one, what's the likely return on investment they can hope to achieve? It's a difficult question to answer. I understand, but what sort of enhancements, what sort of productivity gains can you offer with your system to help them with their ROI?
Yeah, so in terms of ROI, as you say, it's quite difficult to put one figure on it, but we're seeing ROIs anywhere between 6 months to a couple of years. In terms of productivity, we're seeing pick rates or presentation rates of 250 totes per hour in terms of picking efficiencies with our technologies. So really, the amount of headcount that you would be looking for in an operation would be greatly reduced compared to that of a traditional manual solution.
It's a question of doing the maths, isn't it? As it always is in these cases. And one of the things that came out from my meeting with your colleagues in Rotterdam last week was the density of storage versus an Exotex system. In a comparable installation, you would have 26, 27 load carriers per square meter with an Exotex system. You'd have 33 load carriers per square meter with AutoStore, and you could have up to 50 with High Robotics. So you talk about headcount, and I'm talking back to you about optimization of cubic meters in warehouse. And of course, with particularly around urban logistics, but in all warehousing, where cost per square meter is now such a consideration, that's already making a very, very compelling argument.
Yeah, I think it's worth remembering that the fact that we can go up to 10 meters as well means that we get a really good use of the cube of the building. So there isn't lots of air or space that's being potentially wasted. I think with also the fact that we are going up to 5 deep means you've got that whole flexibility in terms of how you use that store. So putting your slower movers towards the rear and the faster movers towards the front. And also the fact that we're using the telescoping technology means that we're getting the best of that building volume. Because as you say, the cost of warehousing, certainly in the UK, is an expensive business.
A breaking news, and if this makes the edit, then so be it. 10 meters may not be your final height target, shall we say. I understand that you're working on a system that can go a little bit more than that, so that sounds exciting.
Yeah, that's right. At the moment, we can achieve double deep storage, traditional double deep storage at up to 12 meters. So if you consider that the majority of speculative builds in the UK and Europe are around 14 meters, that means we're really leveraging the storage density that we can achieve with our technology.
And is there any special considerations required for installation at all?
Yeah, so like most automated systems, the floor is absolutely crucial. So we've developed our standard approach to floors with consultants to make sure that our floors can be achieved in terms of flatness and relatively economic in terms of how they're actually poured and built. And when it comes to the storage racking as well, we work with a number of European rack suppliers who know our technology well and have developed standardized solutions for us.
Right, so shelving off the shelf, so to speak.
But that's it. We deal in terms of heights and bays of racking. So it's quite a simple process of working with them, which is actually reducing cost and lead time as well.
And navigation of the robots, is there anything that needs to be sunk into the floor or put up on the racking to help it find its way?
So our robots are all Wi-Fi driven in terms of how they are controlled, in terms of missions that they need to achieve. We use a DM code on the floor for which the robot's looking for, and we give them the sequence of DM codes on the floor for their routing. Upon the racking, we also have DM codes for positioning. and really that's about it.
And is it a sort of a one size fits all system, or can you tailor it to a customer's specific requirements?
So it's completely flexible and scalable as an overall solution, Peter. So one thing that we've seen a number of times with customers in Europe is starting off very small, almost like a proof of concept. So that once the customers then got used to their system, we can easily add racks or robots to that to meet their requirements for future growth.
So it's effectively a relatively modular system. It certainly looked that was the case when I was watching it being demonstrated at Fox Logistics in Rotterdam. They had a pair of shelves with a single run down the middle, and you could easily see how additional blocks could be added to that to add capacity, with a
That's it.
single robot picking on from both sides, from both faces.
Yeah, that's right. So basically, once that software system is in place, adding new robots once they're unpacked and stood up is a relatively straightforward process. So we're talking a number of weeks to bring extra robots on board to actually meet the customer's future requirements.
Aha, software, you say. Right. Now, do you develop that yourself in-house, or do you use a third-party provider to help you there?
So Hi have our own software product called HiQ. We can. It's quite a flexible solution in terms of software in comparison to or to supplement the robots. And there we have a flexibility of when we integrate with other software providers, such as our integration partners, it gives us and them the flexibility of what they want to achieve with the overall solution. So we can start with a very basic robot control system where we are basically being told what to do, all the way through to a almost like a black box approach where we can have a function-rich WCS provided by us.
Right, and I understand there's like a cluster of software which is available should it be required, from sort of ERP through sort of warehouse execution system, equipment scheduling system to help your little robotic guys find their way. Uh,
That's it. So it all depends on that level of integration with our customer, whether that be through a third-party integrator or the end user. But that's all open for discussion with them.
and your route to market is generally through integrators.
Yeah. So at the moment, we work about 90% of our business is through integration partners, and that way we can leverage their experience and their offerings in terms of software, knowledge of implementation, and also service and support. So in the long term, the end user gets a fully compliant working system.
It's a very crowded market and a very exciting marketplace that you're working in. And obviously, the battlefront there is on the quality of the technology, but it's also on sales and service and backup. So, what are High Robotics' credentials when it comes to customer support in Europe?
So we have hotline support for our software 24/7 on offer. We also have hotline support for the resident engineers or engineering teams that are part of our integration partner network. We've got an extensive spare store, which is based in Rotterdam. So all projects have their spares located there. There are consumable spares provided for every solution that we implement, and we do an extensive training program with our end users and operating teams as well, so that those initial contact points to keep the system working are well covered.
So it's all about the uptime, and I understand with certain systems, obviously safety is an issue when you've got personnel entering a place where robots or robotic systems are operating, and there's various ways to crack a nut when it comes to ensuring workplace safety. One thing that caught my eye in Rotterdam was the high safety vest, which I think was, for me anyway, the first time I'd seen such a solution. Is that something you can talk us through, Damien?
Yeah, so the concept here is that we you mentioned about high uptime, and unfortunately, not all systems are perfect, and sometimes there needs to be an engineer intervention. But the end user wants their system to continue running. So the concept of the high vest is that when we access the robot zone, the vest almost like acts as a force field around the operator, so that the robots can continue running. But as they approach the operator with the vest on, the robots will slow down to a stop. So it means that the robots in the large robot zone can continue operating at their normal speed, but the engineer or operative in the zone can do their rectification work in a safe manner.
The demonstration of that was very impressive. So the robots would operate inside effectively an interlocked fenced off area. The engineer would need to put in the access code to enter that area, and as he approaches, or as a robot approaches the engineer, it slows or stops according to the distance to the engineer. So that also enables, as you say, the entire operation to operate at full speed, other than just about where the engineer is present. And the other thing that, talking about safety, that impressed me was the connection to a fire alarm. So, should a fire alarm be triggered within a warehouse, the robots will know where the fire lane is for escape purposes, and ensure they're not actually cluttering that. So they'll be completely clear of that should any fire alarm be triggered. So these little touches to me make your system seem, the technology there really caught my eye, I have to say.
Yeah, I think for me it's the simplicity of the solution. One of the things I personally really like, was attracted to the high technology, is the fact that coming from a background in automated systems, there was always a question of how a customer would go from a manual background into an automated one, and that acceptance of that operation. And the way I see the simplicity of the high solution is it's a great stepping stone from that manual solution into automation, because it's very visual. You can see what's going on. You can see if there is the allocation of goods to person stations. You can see when robots are working or not. So it's actually a really simple solution for those customers looking for that first step into an automated field.
And of course, the key part of any warehouse with a picking system is the workstation, where the pick station where the goods are brought and collected for dispatch. Your high station solution again caught my eye. It seems to be a very safe, intuitive, and high throughput solution.
Yeah, so if we look at high pick system one, where we're using high ports, these are almost like, if you can imagine, an automatic loader and unloader of totes from the robot. And here we're getting, high throughputs of up to 500 presentations per hour per set of high ports. So for larger systems, these could be connected to a conveyor network, for example, across a number of workstations, meaning that SKUs can go across a number of workstations before they go back into the high store. With Hypic System 3 using the companion robots, what we can do there is pick directly from those from the robots in an enclosed safe space. So there's no real risk of any injury or shear injury, for example, for the operator with the robots themselves.
Yes, the high station appears to be effectively a flat surface with a toad-shaped hole in it, which is it's protected by a light curtain,
That's
and
correct. Yeah.
so until the tote is presented, the picker can't get his fingers trapped, for example, when the toad is coming up through that hole with the goods inside. And I also understood that, and this is quite a challenge with any warehouse, when we talk about bottlenecks, the system can operate up to the speed that a human can and beyond. So the bottleneck is actually the speed at which a human can physically pick from the totes. So that's a tremendous achievement.
Yeah. So the key with any goods to person solution is not necessarily how the stock or the tote gets to the operator, it's what the operator does with that tote. So one of the capabilities we have at High is looking at how that pick station is arranged and how many orders we can fulfill with the presentation of that tote. Basically increasing the hit rate, the probability of how many orders can I achieve from that tote that arrives on the robot or on the conveyor.
The numbers stack up. They look very impressive, and I have to say, when we look at the system as a whole, you've got ease of installation, relatively high, relatively fast ROI. You've got very dense storage to very good heights. You've got extreme levels of safety. It's a very very compelling argument, and I have to say, I do think it's as I said from the start, it's caught my eye. I have to say, and I've been doing this for quite a few years, and it's quite rare that something jumps out at me like that. A hardened old hat that I am.
That's it's great to hear, Peter. I think for me it is we've talked about it, the flexibility, the scalability, the fact that it is so visual as well, and so adaptable in terms of different solutions and situations. Yeah, we've if you look at, for example, in apparel industries with peaks, having a large enough fleet to cope with those peaks. We can adapt that solution to meet those demands, whether it will be the number of retrievals that we make or how many orders we have open on a pick station, for example. So
Yeah.
yeah, I think we touch a lot of we tick a lot of boxes when customers are looking for those selection criteria.
Well, Damien, the time has flown by in our conversation, and I think we're crashing towards our allocated 30-minute limit. So I just want to say thank you very much for joining me today. It's been fascinating learning about high robotics and its technologies today and last week in Rotterdam. And I wish you and the company all the best for the future.
Many thanks, Peter. It's been a pleasure.
So it just remains for me to thank you, the listener, for tuning in today. Look out for the next edition of Logistics Business Conversations, wherever you get your podcasts. Until then, it's goodbye from me. Goodbye.